Hello, let's continue our Sudoku adventure with For Lillian by Rangsk. That's me. So I made this puzzle in celebration of Puzzle 600, but it also coincides with the birth of my daughter Lillian, who was born on September 18th. So it's a lily petals for Lillian, as well as our 9 and 18. Now, this puzzle is very difficult. Normally it would not have been approved for this series because it is too difficult for this series. However, I'm making an exception because of Puzzle 600 and because of Lillian. So it is a puzzle deserving of her. So I apologize if you weren't able to solve it and you came here for help. I am here to help. All right, so let's go over the rules first. We do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these petals. The petals have a line in the center. The line is the only important part. The little dots, the petal part, it's all just decoration. But the line in the center is what we care about. And you need to pay close attention to which cells the line actually touches. So they all touch 3 cells. These three, etc. These are Renban lines. So digits on the line form a set of non-repeating consecutive digits in any order. So pick 3 consecutive digits, like 2, 3, 4 is a consecutive set of 3 digits, and the order doesn't matter. So we could do 4, 2, 3 if we wanted. What we can't do is 5, 2, 3, because 2, 3, 5 is not a consecutive set of digits. We're missing the 4, right? All right, and in addition to that, we do have these killer cages in the grid. These 2 sum to 9, these 4 sum to 18, and that's it. Those are the rules. There is a link in the description if you'd like to try it yourself, and I'm going to get started right now. All right, and obviously this is a walkthrough. I have already solved this because I created the puzzle. All right, so let's start with these cages here. First, we're going to start with this 18 cage. So you can think about how to make 18. It's probably not that hard to think about how to make 18, but it might be even easier to think about the 2 cells the 18 doesn't touch in this box, because the box sums to 21. If these 4 sum to 18, then these 2 need to sum to 3 because 18 plus 3 is 21. Well, 2 digits that sum to 3, that makes that a 1-2 pair. We call that the outies. So the outies of a cage are usually interesting to think about. Now this 9 cage is either 3, 6, or 4, 5. We don't know which one yet, but it does mean that these 2 cells will be the other 3, 6, or 4, 5. We can't make this like 3, 4, right? Because this won't add to 9. These are either going to be 3, 6, or these are going to be 4, 5, but I'm not going to fill that yet. All right, there's some properties about how these Renbans are laid out that I want to talk about first before we continue, because these are properties we're going to utilize. First thing is, let's just call this cell green. Where does green go in this box? Whatever this digit is, we'll call that green. Where does it go in this box? Well, it can't repeat in this column, so it's one of these 4 cells, but it also can't repeat on the Renban. Remember, Renbans, you can't repeat digits. So the green ends up over here on this Renban. So these Renbans are related because they share a digit. Not only that, this cell here has to go on this Renban for the same reason, right? It can't go in the column, can't repeat on this Renban. So actually, these 2 Renbans share 2 digits, which means they're either exactly the same or there's gonna, well, let's think about that case first. Can they be exactly the same? And the answer is they can't, because if they are exactly the same, then I would need the same digit here and here. Remember, they both already have green and blue. So there'd be some third digit. I don't need to give it a color, but there'd be some third digit that would need to go on this line, and a third digit needs to go on this line, but they'd both be in the same box. So that means that these share 2 digits, and then a third digit is different in each of these. So if you think about it, that actually means that these 2 digits need to be consecutive. They cannot be 2 apart from each other. Because if they were 2 apart from each other, like let's say this was, I'm just going to pick 2 digits that are 2 apart, 3 and 5. If this was 3 and 5, and if this works for any 2 digits that are 2 apart from each other, then then this has a 3 on it, and this has a 5 on it, and they would both need a 4 to bridge the gap between the 3 and 5, right? The shared digit would be the same. Because we know the shared digit is an extreme digit on one end or the other, one of them is on the lower end and one of them's on the higher end. That means that these have to be 2 consecutive digits, right? If this was, say, 3, 4, 5, right? If I do 3, 4, 5, then the 3 and the 4 would be shared. There'd be a 3 on here, and then this would be 3, 6 in some order. I hope that makes sense. Because this would be, not 3, 6. Sorry, did I do that wrong? 3, 4, 5. My example is bad. There'd be a 4 up here, there'd be a 3 down here. This could be 3, 4, 5, and this could be 2, 3, 4. Right, I did that wrong. So this would be 2, 3, 4. This would be 3, 4, 5. You notice the 2 and the 5 that end up in here that aren't these digits are going to be on either end of that string of digits. Okay, so important properties to remember. And this does the exact same thing. This is the same exact setup. So we can say the exact same thing about these as well. So what that means is because the extremes are in here, these can't be 1 or 6. You think about it, because then, like if this was 5, 6, right, we lose the ability for us to have both extremes. There's nothing higher than 6 in this puzzle. We can't put a 7 in here. So that means this can't be a 6, but it also means this can't be a 6. If you want, I could fill 2, 3, 4, 5 here, because they can't be 1 or 6. And then the 1, 2 pair removes 2 from these. And so these are from 3, 4, 5. But remember, these have to add to 9, because these add to 9, and this is a 1, 2 pair. So these have to add to 9. These are the 2 digits that add to 9 that aren't in here. And so that leaves just 4, 5 for here. They can't be 3, 6, because 6 is gone. So we can do that. And then now that these are 4, 5, 2 is too small, because it's not consecutive with 4 or 5. So we end up with this pattern here. 4, 5, 4, 5, and then 3, 4, 5 up here. All right. If you figured all that out, that's already really, really good. But there is more to figure out in this puzzle. All right. So the next question to ask, or I guess, sorry, the next thing to point out, we don't really have a question right now, is that because these are consecutive and these are consecutive, we must include the 4. There's a few ways to think about it. It seems pretty obvious, actually, because you can't be 3, 5. But one nice way to think about this would be you need 1 even digit and 1 odd digit in order to be consecutive, and the only even digit available is 4. So we need a 4 in one of these two and a 4 in one of these two, which means we're either going to have a 4 like this, 2 4s like this, or we're going to have 2 4s like this. So you might play around with that a bit and finally ask the question, what happens if this cell then is 4? Well, if this is a 4, think about this Ren band in the box with it. It ends up being a 1, 2, 3. In addition to that, you might have thought about 4, 5 here. And remember, we need one of the extremes. We need both extremes. So we need a 3 and a 6 in here. If there's a 3 and a 6 in here, the extremes of 3, 4, 5 and 4, 5, 6, then where does 6 go in this column? We can't put a 6 here because of the 3, 6 pair. And we can't put a 6 here because the Ren band doesn't work, because we can't use the 4. We can't do 6, 5, 4. So there's nowhere to put 6 in this column. So actually that doesn't work. We can't put a 4 in the blue cell, which means the 4s end up over here in this diagonal instead. That does make this a 5. Remember, the 4, 5 here does make this 3, 4, 5, 6, which puts a 1, 2 pair here. And then this can't be 5 and these can't be 4. So this has a 5 in it and this has a 4 in it, based on this geometry we talked about over here. And this isn't a 4 now. All right, so we can do a little bit more Sudoku here. This ends up being 3, 4, 6. That's not a 4. This ends up being 1, 2, 5. All right, so one thing you may notice is that we cannot put a 1 into these 4 cells, because if we try to put a 1 into these 4 cells, they just don't work. It doesn't work with the 4. And remember, both of these, so there is a 4 in one of these. Both of these Renbands has a 4 on them. And if a Renband with a 4 on it, that's 3 length, can't have a 1 on it. So the 1 ends up over here in this box. That points down, removing 1 from this cell. So you might fiddle around a bit more and think about what happens if this is a 5, right? We're down to 3 or 5 here. What happens if it's a 5? Well, if you recall, a 5 here is going to put 5 on here. These are going to end up being 3, 4, 5, 6, just like these did, with a little bit of cleanup. So the question is, where does 2 go in this box? Well, the problem is this is now a 2, because it can't be 1 and it can't be 5. And so we have nowhere to put 2 in this box. That's broken. So we have to be able to put a 2. But anyway, we have to be able to do something with the 2. So this ends up being a 3. It's not a 5. And now I can get rid of my colors. All right. So now that we know this is a 3, this is 3, 4, we know that these end up being the 3 and the 4 with a 2 and a 5. And so this ends up being a 1, 6 pair. All right. Now, if this is a 3, this cannot be 1, 2, 3. So this ends up being 4, 5, 6. And the 4 has only one place to go. That places this 4 as well. And then also, this can't have a 4 on it, so it ends up being 1, 2, 3. And this ends up being a 5, 6 pair. So we have this 5, 6 pair, 1, 2, 3. This is from 1, 2, 3. It's not a 3. In fact, we just need a 1, 2 pair in here. So we get all this penciling. Now, if this has 3 and 4 on it, this could be 2 or 5. Yeah, we know that. What is actually the next step here? Right, these 5s point, so this can't actually be 5. So that's a 2. That's 1 and 2. That places the 2 on this ren band. It places 1 and 2 here, 1 and 2 here. Places the 5 and the 1 here. We get the 2. We get the 6 and 1. We get our 3 and our 5. We get our 6 and our 5. That's a 6. That's a 5. We get our 3 and our 1. We get our 3, 5. We get a deep, deep do in the corner. Of course, had to include that. That's 4 and 6. That's 6, 4, and 3. That's 3 and 6. And we are done. So really, really hard puzzle. Thinking about the interaction of how this works and this works was really, really important for this puzzle. And then also thinking about these ren bands and how these digits affect them. And then a little bit of a fiddly bit here where this couldn't be 5, which hopefully maybe someone has another way to move forward from there, but that was the cleanest I could find. Cool. Well, hope you enjoyed this little tribute to Lillian. 600 Sudoku adventure puzzles. Can you believe it? That is a lot. That's a lot of puzzles. All of them are available in the tracking sheet. If you missed any, you're welcome to go back there. And then also it's actually more than 600 puzzles because some of the puzzle numbers have more than one puzzle. Like puzzle 500 was actually, I don't remember exactly how many, at least 10 puzzles, I think, in a chain. And then also we had some of them where there were like 3 puzzles grouped together, things like that. So actually more than 600. So it's pretty amazing. Hope you enjoyed this. I hope you're enjoying the series. And if you did, why not leave a like, subscribe, and a kind comment below.